Yeah, amazing. Yeah, maybe we could do like just a quick overview of TraceLab and just dive into it
Yeah,
a little bit.
yeah, sure. So TraceLab was a work from someone in my lab named Kanju, and basically the problem we were trying to he's actually built some amazing things in everything. I don't know if you've heard of NanoFlow and stuff like that. That's all his work. And so when you notice is when you start doing trying to look at these inference things, there you look at the sweet bench traces, and they're actually just like not at all. Sort of realistic for how it should actually look like. Like there's like 900 tokens, like random tool calls, etc. And if you use Claude all the time, like that's like not at all how it works. You have long tool calls and parallel tool calls. You know, you'll be sitting there for 5 minutes as Claude. Maybe looks at these things. And so we were like, uh, how do I make a realistic thing so that we can actually hill climb on problems that are actually worth climbing? It's like very similar to our space. It's like what's a good hill to climb? And so what we did, or what he did was, he led this project where we actually harvested like 40K traces from Codex, Claude, and real usage. So like there's people in our lab that are actually, working on real projects. And then sort of did an analysis of sort of trends of like for example like there's random compactions that happen in the Claude thing, and you'll try to see the prefix like tokens will go up, and then you'll just see it after like a 5 minute period randomly go down. And he just did such a wonderful analysis of like where the costs come from, what are the patterns of usage, how does this affect prefix caching, all these things, and it's like super in depth. And uh, if you really want to really understand how maybe these coding agents are actually being used and how you're using it or are using it and we don't even know, I would definitely recommend checking out the paper. And you can actually, I forgot to mention, you can actually plug in, you have a tool, there's a tool here. It's tracelab.cs.washington.edu, and you can actually very easily put your own Claude usage or Codex usage, and it will automatically do analysis for you. And you have an agent that you can ask about your own data. So you can really understand these things.
Yeah, it's so cool. There's so many cool aspects to that. I guess it's interesting that we sort of Cloud Code feels like such a black box. I have no idea what it's doing. Yeah.
Yeah, exactly. And it's fun. It's like it's kind of crazy actually when you start looking at it. Like, for example, like how like prefix cache hits and misses happen and changes, and like if you wait, most of the time the caches come from like you just waiting around, and like when you're typing like quickly or like you're working quite quickly, like you guys do performance, but then just the characteristics of how these guys are, how the coding agents are, being managed and stuff like that, and how it actually uses tokens and tool calls, etc. um, is really interesting. Like I remember one time, like the tool call, and maybe this is like not totally new, but like how long tailed it is. It was like a super small, like a couple percent of the tool calls take up like 90% of the tool call time, and just like all these different sort of things. And it begs questions of like, if I design a serving engine, can I even do a tool call prediction? Or like, for example, if I see a tool call happen, can I predict how long it'll take? And maybe I can do clever things like offload the KV cache if I know it's going to take a long time and start putting on new requests. Or if I know it's going to return quickly, make sure I pin the KV cache so it doesn't get kicked out. And so there are all these new sort of optimizations you can do once you really understand the workload.
Yeah, I've learned something today. I think that that's
Yeah,
so cool. It's
it's
like a VLLM for agent runtime. I think I've heard this idea where it's like you're having is that the right idea? You have a
like uh, like
particular
like a VLM for, I guess it's more so just trying to, I guess, like well, TraceLab itself is, I guess, the analysis, and then like it's almost like I think of the cache stuff as like almost caching how we do it on our computers, like on the hardware. Like it has all these advanced mechanisms for how the like in a core you have a cache and a prefetcher and all these things. And so, it's a lot of times, they've had decades of experience of like, what are the workloads and like, maybe we do this, this, this. And I think now this is starting to come to like the MLSS world. And really understanding, and the predicate for that is really understanding your workloads. And I think, sci-fi TraceLab helps really understand your workloads.
Yeah, super cool. I guess like one last thing on this is I remember we recently had an engineering offsite at Weaviate where it was a lot about like us, we're really trying to figure out the best way to use Claude Code. And the I guess one thing for me was this use of like Git work trees is now really interesting, and you have like this Claude
Mhm.
superpowers plugin, and it's gonna do the work trees, and that feel like that just takes the parallel thinking to a whole nother level because now it's
It's
not
I,
only
I've I've never seen. It's crazy because like work trees have been there forever, but I've never seen so
yeah.
many quad sessions open with it's like tons of different work trees. It's like the one Git feature in my mind. Maybe I'm a Git simpleton, but it went from zero to hero real quick.
Yeah, I feel like you'd have to be pretty split brain to be using that prior because
Ex-
you yeah.
Exactly.
Yeah. Even yeah, awesome. Well, yeah, I mean, Matthew, thanks so much for joining the WeBay podcast. It's been such a fun conversation. Learned so much about re-ranking, and obviously this latest talk about TraceLabs is super exciting stuff. Thanks again. Thank you so much.
Thank you so much for having me. I really enjoyed my time here.